All right, so what we want to do here is look at the adding and subtracting rational expressions practice test. And specifically, we're going to be doing problem number 10, okay? So this guy right here, so I've already copied it to our notepad so we can get started right away. Okay, so the idea here is you first want to look at factoring things, seeing what you can clean up. Can I cancel anything? Then you'd want to find the LCD, okay? And once you have the LCD, you want to use the same process you use with fractions if you were adding fractions, right? You're working with rational expressions, so the process is the same from fractions. Okay, so that being said, let's factor everything. So the numerator here, let me just put this down here. I'll say this is 5 times the quantity x plus 2, okay? Because this is 5x and this is 10, so I could just pull out a 5. Down here, if I look at these guys, I notice that everything is an even number, right? I have 8, I have 20, and I have 8, right? So everything's going to be divisible by 2, but also it would be divisible by 4, right? 8 divided by 4 is 2, and 20 divided by 4 is 5. So I know I can pull a 4 out, okay, before I do anything else. And then notice that you have x to the 4th power, x cubed, and x squared. So I can pull out an x squared, right? So I'm going to pull that out, okay? So what's left inside would be, if I divide 8 by 4, I get 2. X to the 4th divided by x squared is x squared. And then we continue. We have 20 divided by 4 would be 5. X cubed divided by x squared is x. And then we would have 8 divided by 4, which is 2. X squared over x squared is 1, okay? Now I can further factor this. If I come down here and just do this off to the side, well, basically, if I have a prime number here, I always want to think about doing reverse FOIL versus the AC method because it's a little bit quicker. So I'm going to put a 2x here and an x here because, again, 2x times x will give me 2x squared. Now, this guy right here, this 2, can only come, since it's a prime number and everything's positive here, it's only going to come from 1 times 2. So the question is, do I want a 1 here and a 2 here, or do I want to reverse it? Well, it turns out that this is the order you want because the outer here would be 4x, and then your inner here would be 1x, right? So 4x plus 1x would give you 5x. So this is how we're going to factor this guy, okay? So now I can just replace this right here with this right here. So I can do the quantity 2x plus 1, okay, times the quantity x plus 2. Now, what we see is that I can actually cancel this with this, okay? So this guy right here is going to turn into, if we come down here, I'll just say it's 5 over 4x squared, okay, times the quantity 2x plus 1, okay? So let's erase this. We don't need this anymore. We know what happened there. And I'm going to put an equal sign out here, okay? And we'll do some more stuff with this. I'm just going to work on this real quick. So what I'm going to say is I have x squared plus 3x. So I'm going to write that as x times the quantity. I'm just pulling an x out. So x plus 3, okay? And then down here, again, I'm just going to try to factor this. Notice once again that everything's even, right? So you know you can pull out a 2, but also everything there is divisible by 4, right? 8's divisible by 4, so is 20, so is 12. So if I pulled out a 4, okay, and then also because I have x cubed, x to the 4th, and x to the 5th, I could pull out an x cubed, okay? So what this is going to give me, and let me make that a little bit better, what this is going to give me inside, this would be 2x squared, okay? And then plus, this would be 5x, and then minus, this would be 3 by itself, right? Because x cubed divided by x cubed is 1. So now I need to factor this guy. Okay, let me do this down here. Let me change my ink back up. So if I wanted to factor that, again, if this is prime right here, this 2, didn't mean to highlight the x there. If the 2 is prime, then you want to use reverse FOIL. So I'm going to do 2x, and I'm going to do x. And again, we have a nice clean prime number of 3 there. And it's negative, so I know the signs have to be different, right? So 3 is only going to come from 1 times 3. But it's either got to be negative 1 times positive 3, or positive 1 times negative 3. Okay, so what do I want? Well, the term here is 5x, right? So that means I want to do 3 here, and I want it to be plus, and I want minus 1 here, right? The outer would be 6x, the inner would be minus x. That would give you a correct middle term of 5x. So again, let me just replace this with this 2x minus 1, and then times this x plus 3, okay? Now, you'll see that you can cancel this with this, okay? And also, I can cancel this x here, right, with 1x from there. So this would be x squared now. So I'm going to go ahead and say this is plus. This is canceled completely in the numerator, so I'm just going to put a big fat 1 there, okay? In the denominator, I now have 4x squared times the quantity 2x minus 1, okay? So let's erase this. And let's now bring this up here, okay? And I think the problem from here is pretty simple. The hardest part is just factoring things and seeing what you can cancel. So what is the LCD? What is the LCD? Again, when you think about it, it's the LCM, or the least common multiple, of the denominators. So you have a 4x squared and a 4x squared. So that's going to go in, okay? And then you have this 2x plus 1, so that's going to go in. And then you have this 2x minus 1, so that's going to go in. And you don't need that visible multiplication symbol there, just put it there. But basically what you're going to do is you're going to look at each fraction and say, hey, what am I missing, right, in my denominator from the LCD? So for this one, I'm missing the 2x minus 1, and for this one, I'm missing the 2x plus 1, right? Both of them have the 4x squared. So let me just slide this down so we can maybe fit this. I'm just going to multiply this numerator and denominator by the quantity 2x minus 1, because that's what I'm missing, okay? And I don't know if I can fit this on the screen, but I'm going to try. Let me move this down. Let me move this down, okay? So this guy is going to get multiplied by what it's missing, so 2x plus 1, and then 2x plus 1 like this. Okay, so we're done with that. So now it's just a matter of doing some basic algebra, okay? So we have 5 times 2x, which would be 10x, and then 5 times negative 1 would be minus 5, okay? And then plus, you have 1 times 2x, and then 1 times 1. So basically, 1 times anything is itself. So I'm just going to write 2x plus 1 here, okay? Now, you can write this over the common denominator, which is 4x squared, okay, times the quantity 2x plus 1 times the quantity 2x minus 1, okay? So let's scroll down and get a little bit of room going here. And what can we do? Well, we see that 10x and 2x would be 12x, okay? And then negative 5 plus 1 would basically be negative 4. And this is over, again, if we think about it, we have 4x squared multiplied by the 2x plus 1 multiplied by the 2x minus 1. Okay, so far so good. We're not at our final answer yet because, again, we always want to think about, once we have an answer, if we had a fraction, if we had something like, let's say, 2/4, we want to see if we can cancel things and write it in a simpler form. So we want to write this as 1/2 because the numerator and denominator are each divisible by 2. Same thing here, right? We're always looking to simplify. So 12x minus 4, there's a common factor of 4. So I can pull that out, okay? So this would be 3x minus 1 inside. Over here, you notice you have your 4x squared, again, times your 2x plus 1 times your 2x minus 1. Well, I can cancel this 4 here with this 4 here, right? It's perfectly legal. This is a factor, this is a factor. So I can cancel common factors. So this is going to give me my final answer, which is simplified, of 3x minus 1 over, you're going to have x squared, okay, times the quantity 2x plus 1 times the quantity 2x minus 1.